Hey Techno Studs, in this video we're going to talk about link aggregation. Link aggregation is when we combine multiple links together to create more bandwidth between two switches. As an example, I might have two switches that have ports on it that operate at 100 megabits per second. If I were to just connect one of those links together, then perhaps that's not enough bandwidth between those two switches to facilitate all of my traffic. I may need more than 100 megabits per second between those two switches. So what I can do is I can plug in multiple ports, let's for this example say 4 of those ports, and aggregate them together, and now I have one link between those switches that operates at 400 megabits per second. So let's talk about link aggregation. In this video, I'm going to explain a little more about link aggregation, and then I'm going to relate it to spanning tree protocol. They serve very different purposes, spanning tree protocol and link aggregation. Although there are some similarities, so I just wanted to cover what some of those similarities are and what some of the differences are. Then we're going to get into some configuration guidelines when it comes to link aggregation. In our last module, we talked about spanning tree protocol. During that process, we actually created multiple links between our switches. We created 2 links between every single switch to create redundancy. But we also talked a lot about spanning tree protocol and how spanning tree protocol allows this to happen because it eliminates or shuts down some of these extra links. It will turn off some of these links so they're not all operating. That mitigates against any kind of loops. Well, link aggregation allows us to actually utilize those links. What I can do is I can combine these 2 links over here into one link, therefore increasing the amount of bandwidth that I have across there. And I can do it for 2, 3, 4, 5, up to 8 different links I can band together. So if these are 100 megabit per second connections, then I can band up to 8 of them together and get 800 megabits per second between these switches. If they're gigabit connections, I can band up to 8 of them and get 8 gigabits per second between these switches. So link aggregation is great, and it also allows for that redundancy also, because if one of those links dies, then the connection still remains up and running. Now, link aggregation goes by many different names. So link aggregation is the most common, but you'll also hear the term bundling, bonding, channeling, teaming. Cisco calls it EtherChannels. We'll talk more about EtherChannels and what EtherChannels look like. So midway through this module, we're actually going to switch our terminology and just start talking about EtherChannels. But I'm going to talk about link aggregation right now because link aggregation is not Cisco specific. So let's get more in depth into link aggregation. Now, I like to relate it to spanning tree protocol because there are some similarities. There's some overlaps between link aggregation and spanning tree protocol. But once again, they serve 2 very different purposes. Spanning tree protocol actively looks for redundant links and shuts them down and allows you to mitigate against layer 2 loops that happen and broadcast storms that happen. Link aggregation allows us to bundle those links together to create more bandwidth between our switches. But let's take a look at some of the similarities and differences. So first of all, the link aggregation creates redundancy between 2 switches. So I will bond the links between 2 switches together to create some redundancy within there. So if any one of those links fail, it's still up and running. Spanning tree protocol allows us to create redundancy between many different switches. So link aggregation doesn't do that. I mean, we can have links between many different switches, but they can't be all bonded together into one aggregation. So the other thing that link aggregation allows us to do is do some load sharing amongst those different Ethernet cables. There's some different ways that we can load balance, or we can share the load between those different links. And so it's kind of interesting how some of that does that, and beyond the scope of this course. But just know that link aggregation really just shares the load amongst all of those links with those bonded links together. Spanning tree protocol doesn't really have that capability. They don't really have a load sharing amongst the multiple links. And the one exception to that is that we can actually do a per VLAN spanning tree protocol. So if we wanted to engineer our network so some VLANs use one link, other VLANs use other links, we can actually divide that up and have some load sharing. But it doesn't dynamically change. So the load sharing is just based per VLAN. And you could have one VLAN that just needs a ton of data, where another VLAN doesn't need as much bandwidth between those switches. And spanning tree protocol is not going to adjust for that. Versus link aggregation will. We can utilize all of those links. All right. Link aggregation increases the bandwidth of a link. And once again, spanning tree protocol has just a dedicated link per VLAN, very similar to what I just had mentioned. The link aggregation does not eliminate loops that happen within your network. So it can eliminate the need for spanning tree protocol just between the links that are aggregated, but it doesn't involve other links and other connections throughout your network. And we want multiple backups to our backups. And so with all of that, we still need spanning tree protocol because it really eliminates the loops in your network. So those are some of the similarities and differences between link aggregation and spanning tree protocol. Now, as I mentioned, you can have anywhere from 2 to 8 of these links bonded together to combine their bandwidth. But there are some configuration guidelines along this. First of all, what you should know is they don't have to be physically contiguous ports. So what I mean by that is they don't have to be right next to each other on the switch. This port could be 01 and this port could be 048. I can still link them up. Now, generally speaking, we do have them right next to each other on the switch. We do have it. I like to usually put mine right towards the end of the switch, and I have it grouped up all together. And 047 and 48, or 045, 46, 47, 48, and group them up that way. It just makes more sense when you're looking at the configuration. It makes more sense when you're plugging in, but it doesn't have to be set up that way. The other thing is that you must have your configurations match on both sides, and there's several ways that they must match. First of all is the speed and duplex must be the same on both sides in order for this communication to happen. Otherwise, that they're not going to make that same connection. Also, they must be the same type of port. So on this side could be an access port, and this could be an access port as well, or trunk ports on both sides, or routed ports on both sides. So they must match from that perspective also. The VLANs match, so need to match. So if this is an access port and it's on VLAN 10, then this side also needs to be set up for VLAN 10. So the VLANs need to be matched. If you are configuring these, you can configure still the individual ports. In fact, we're going to have to do that to bring them together onto the same link aggregation. But then I recommend configuring the actual link aggregation as a whole, because if you put 2 different configurations on each one of these ports, then it will not function correctly. So those configurations need to match. And once again, when we get into our demo, I'll show you kind of what that looks like. Some limitations of link aggregation is you can only bind up to 8 connections at any given time. So that's one of the limitations. Another limitation is you can't combine a fast Ethernet and a Giga Ethernet at the same time. So this side can't be at 100 meg and this side at a 1 gigabit per second. That type of connection isn't going to be allowed of combining that. They all have to be 100 meg or they all have to be a gigabit connection. Also, there's a limit on how many ether channels you can have on a single switch or link aggregations on a single switch. For instance, a 2960 can only have up to 6 of these ether channels on a switch. So there is some limitations on how many of these ether channels or how many of these link aggregations I create. So we talked about link aggregation and what link aggregation looked like versus spanning tree protocol, and then I gave you a few configuration guidelines. So they're pretty cool. I love link aggregations and how we can combine to create more bandwidth between these two switches. So let's take our next step and take a look at some of the protocols in our next video.